What's going on, everybody, and welcome to part 9 of our self-driving car with Python, and it just so happens to be Grand Theft Auto 5 tutorial series. Where I left off, I was kind of explaining the next steps we were going to take, since some people might have skipped that video because they don't like to listen to me talk. You can just make sure you clone the directory that most likely, if you're watching this right away, you might be able to clone this main direct. Well, you could clone the main directory always, but probably what you need is actually going to be in tutorial codes by then. But make sure you just have the main.py, grab a screen, draw lanes, draw keys, and all that. And main.py should look like this. It should have the ROI and the process image and all that stuff. Once you have that, you're ready to rumble. I've got it already put into here. So basically, I'm going to first start by pulling up main.py. And basically, like, what we're going to be trying to do here is training a neural network. Now, the neural network, we're going to be working with image data, so immediately that should probably signal to you we're going to be using a convolutional neural network. If you're not familiar with deep learning in Python, you can come to the deep learning tutorial series. It's part of this huge machine learning series, but you can also, if you are already familiar with machine learning, kind of just jump into the deep learning part, which is somewhere there. Okay, and this is with, first we start with TensorFlow, and then we eventually get into TF-Learn, which is kind of towards the end, which is here. So anyway, if you need to learn more about all of these things, there's plenty of information on my website. So sometimes people get angry when I'm like copy and pasting code, but I don't really see the point of like reteaching something when I've already taught exactly that thing. So I just don't like to waste time. So anyway, yeah, so what you should start with is just this kind of main.py here, and we can actually probably clean this one up quite a bit. But the first thing that we need to do, or like the first step if we're going to have a self-driving car that's going to learn from a neural network, is we need training data. So the input data to the neural network, whether we're training or we're actually using the neural network, the input data is going to be the frames, right? It's going to be the pixel data. If it's a convolutional neural network. We could have other input data too, but that's what we are going to do. So we're going to throw in the pixel data, and then the output should be the actions. It should be what we hope the vehicle to do. So to train it initially, there's a few things we could do. We could use the previous code that sort of did okay, but that probably not work the best. I mean, we could start with that, I suppose, but instead I think probably the best thing to do would be to manually drive the scooter a bunch and teach the neural network this is how it's done. So that's kind of what I want to, the way I'm going to do it. Now, the problem is we need some way to record the keys that we press, and I didn't know of any way to do that in Python without actually having the Python window that was tracking the keys in focus. So I took to Twitter, asked around, and a box of hats answered me and provided some code. So the first thing we're going to do is we're going to make a new script. And this one will be in the GitHub. So actually probably when you clone the GitHub, you probably should already have this. But I'm going to make it because I don't have it up yet. But actually when you do clone it, unless I make a mistake, this will be there. So anyways, that's this script. And let me make it bigger-ish. Let's do 16. And this is not the code, but I'm just going to copy and paste in the code. Okay, so this is getKeys.py. We're going to be using, again, pywin32. And in the last video, I didn't specify what to do to get that, so it might not totally be clear what you should download. So what you want is pywin32, and where you get it is... Am I blind? Here we go. The unofficial Windows binaries for Python. This is probably the best place to go to get it. Pywin32. Oops, I clicked on the wrong freaking thing. There we go. We're still here. All right. Oh my goodness. Back. Okay. Oh, there we go. Sorry. Now, download the wheel that applies to you. So Python 3.6, AMD 64. That's 64-bit Python. So make sure you get the one that applies to you. Anyway, this is actually a pretty simple script. I'm embarrassed that I couldn't figure it out, but again, this is another thing I tried to figure out. I just couldn't do it. But anyway, yeah, so this just goes through all the characters that one could plausibly press, implements them to the key list, and then the key check function just simply checks your state and sees what keys are being pressed. I have no idea why. I must have just over copied. Anyway, so now what we can do is we can import, from get keys, import key check, and now we can get the key presses. Cool. So I'm going to close out of that. There's get keys. And so yeah, so let's go ahead and do that. From get keys, import key underscore press. All right, now what we're going to do is basically we need to have a function that will convert the pressed keys to a one-hot array. Again, this is a pretty fundamental thing to neural networks, so if you're not familiar, you can check out the tutorial series there. And in fact, let me just make this big. Configure idle and 18. Cool. So now what we're going to do, or what I'm going to do, is define keys to output. And then we're just going to say keys. We're going to pass in the keys that are currently pressed. And then basically what we want to do is convert this to a one-hot array, basically that will be the keys of the following keys. So it'll be either an A, I have caps lock, A, W, and D. So we're not really going to worry about slowing down for now. It's an unnecessary move. So so basically AWD. So this is take a left, just go straight, take a right. Okay. And then later on we can kind of, so first of all, we are obviously ignoring A and W, go straight and turn, because like I said, we're just going to assume we're always going to be going straight. But of course, in reality, you'd also have an S, you'd have SA, you'd have probably not SW, but you could, if you wanted to do a burnout, you could have WD, you could have DS, and so on. So there's a lot of other combinations, but for now we're going to keep it super simple, because again, right now, just trying to see mostly, like, is this even going to work? So right now we're just kind of testing things. So we're going to start with output. It's not a constant. It is going to change. 0, 0, 0. So right now we have nothing. And if we have a 1 here, that means it's a Boolean value, right? It's A. We're going to take a left. If we had a 1 here, it would be forward and so on. So now what we're going to say is just a bunch of if statements. So if capital A is in keys, then we're going to say output 0th equals 1. So this will now be a 1. And then we're just going to copy this and then just do elif else. So elif D is in keys, that would be 0, 1, 2. So 2 equals 1. Else. If else, actually we don't need an if statement at all. We're just going to say else output 1 equals 1. Now, this is crucial. Make sure you've got this set up correctly. Make sure you've got 0, 1, and 2 accounted for in this exact order. If you mess this up, you're going to really be kicking yourself down the line. Finally, what we're going to say is return output. And I'm just going to confirm because I don't want to mess this up. 0th, which is AWD. So 0, 1, 2, which is take a right, 1, 1 forward. Good. I think that looked good. So we return the output and we're good to go. Now what we're going to do here is we don't need to ROI. We don't need process image. We don't even need these turns. We could use the countdown. So I just deleted everything. Basically, we just have keys to output. We've got this like sleep, which is kind of poorly placed. Let me just move it over into here. Like so. Hopefully I'm not screwing up something. All right. Now, before we enter the main function, let's go ahead and say file name equals training underscore data.numpy. And then we're going to say, I need OS. Let's import OS. Also, let me see here. We don't need direct keys or draw lanes Part of me wants to get rid of PyAuto GUI. Someone pointed out that my importing of PyAuto GUI was slowing things down. And in fact, if that's in the GitHub, I'm kind of bummed. I was trying to leave out the import PyAuto GUI because I think I might be the only person that actually needs it, but no, it's there. Darn it. Since I'm thinking about it, I'm just going to go ahead and edit that real quick. Not necessary. Okay, so now, as I was saying, I'm going to leave it there just so it stays. Actually, no, I don't need that because we're not going to be putting up a new screen. We're actually totally done putting up new OpenCV screens, probably for a long time. So yeah, we definitely don't need it. So that'll help frame rate a lot. And in fact, let me get rid of this, and we're not going to be needing this, and we don't need any image show. We don't need to process image. We just need to grab the screen, and then like we can look at the times. So just to kind of show you how quickly we can process now, let me run this also to give me a kind of confirmation that we don't have a typo. Can I import name key press? Really? Do you want to fight? Let's see. Grab screen. Grab screen. Oh, have I called it literally grab screen? No, wait, what did key press? Oh, no, we're... Okay, whew. Dude. Anyway, wrong thing. From get keys, import key underscore press. Get keys, key check. Key check. And we haven't used that actually yet anyways. Wow, that was a big mistake. I don't know. I'm tripping out right now. Anyway, okay, so the countdown has begun. Yeah, wow, check this out. That's how fast we're processing frames now. Like, we've got a really good frame rate. So anyway, and a lot of that is because we're not showing the OpenCV frames. But a lot of it's actually also just because of using grab screen instead. So that made a huge, huge, huge difference with PyWin32, that is. Anyway, so we're importing OS now. Back to what we were doing. Anyway, having some serious brain farts. This probably doesn't end well. Anyway, if os.path.is file, let's check for the file name. So let's just see if it exists, because here's the deal, guys. We're going to need to make almost knocked over my water. We're going to need to make a lot of training data, and chances are you're going to get really bored of doing this. It's not fun. It's not fun to drive a scooter in between the lanes. It's just not enjoyable. So, but we really need to do this first before we do anything serious, I think, because we want to check. We want to see, can this actually be done? So anyway, what's nice in the way that I've kind of coded things is, or that I'm going to code things, is we're going to see if this file exists. If it does, we'll load that data and we'll just keep appending to it. And then every, let's say, so many iterations, we'll save that data. That way we can kind of come and go as we please. So yeah. So if that file exists, great. Let's just say print file exists, loading previous data. Else, print file does not exist, starting fresh. And then also, I guess we should probably define this. So let's say training data equals the list version of np.load file name. And I want to do this just so I can append to it. I'm pretty bad at appending to NumPy array. I just don't know the proper protocol. I don't think you can't just do .append. I don't think. Anyway, training data equals that. Someone wants to improve that because it'll be faster just to use straight up NumPy. Pull request. Okay, so, or just let me know and I'll throw it in there. Probably like half the people that have improved the code haven't done it officially. They just kind of send me a gist or something. Anyway, so, okay, so now we've got the training data. Now we got a countdown. That's fine. Now basically what we want to do is every time we grab the screen, first of all we grab the screen, we've got the region. We want to convert the screen to grayscale. We could keep it in color, but if we can avoid the color thing, it would be nice. Because think about it this way. Can you play Grand Theft Auto 5 in grayscale? Yeah. So if you could do it, a neural network should figure it out, right? That's the kind of whole point. So, and if we can trim down that data, because like grayscale is 1/3 the size of fully RGB data. So we want to scale it down if we can. So we are going to do that. So we're going to say now, screen equals cv2 dot convert color. We're going to convert the color of our screen, and we're going to do cv2 dot all caps color underscore bgr data to gray data. Now, we also finally want to resize this. To start, let's keep it nice and small. We're just going to say screen equals cv2 dot resize. Let's do the screen, and we'll do 80 by 60. Eventually, I wouldn't mind getting that a little bigger, but I think for now, for just seeing the lanes, 80 by 60 should be more than enough. Feel free to visualize that yourself, the 80 by 60. Like when we save the data, we can pull it up and look at it. I'll probably forget to show you, but you could do that. And you should be able to see that, okay, yeah, I could see how you could play with that size. Like you might want to blow up an 80 by 60, but it would be, truly of that resolution, but you could still stay within lanes at 80 by 60. Also for a neural network, a convolutional neural network, 80 by 60 is actually kind of large. So anyway, so we've resized, and then now let's go ahead and check for the keys. So we're going to say keys equals key check, and then we're going to say the output for the actual training output that we want. We're going to say keys to output, and that'll be the keys. And then finally, we're going to just do training underscore data dot append screen comma output, and that's it. So now what we want to do is we'll say, so this is just basically appending constantly. Sorry if you can hear those jets flying over my house, by the way. I called the Navy and I told them that it would be nice if they would just give me a warning every time they fly over, but they don't seem to care. Anyway, what I'm going to do now is, or I suppose the Air Force, but the Air Force and Navy are buddy-buddy. Anyway, moving along. If the len of training data modulo 500 equals 0. So if you were to divide it by 500, would the remainder be 0? If that's the case, let's go ahead and print len training data. And then let's go ahead and np.save file name training data. So save to the file name, save what? Training data. Main. All right. That should do it for creating training data. Let's go. Let's try it. Let's see how it does. So hopefully we'll get some files up in there. Every 500 it'll let us know that we've done something. Also, let me make sure, yeah, we're in first person view. We'll have the countdown. And then basically if you want to stop at any time, later on I'll add a fancy way we could just pause or something. Got to keep that YouTube ad revenue. What we'll do is, for now, you can just kind of tab out and just Control C. So right after you get a 500 frames update, go ahead and Control C or tab out, Control C, and that will stop the script and you won't have any screwed up frames. But later I'll add some way to pause or something probably. But anyway, for now, again, we're just so far from doing any official testing. But anyway, 4, 3, 2, 1, go. We got freaking frames up the wazoo. Now, for this, I'm just going to try to stay kind of in the middle of the screen as best as possible. This scooter is fast. I think I might have a speed mod or something on the scooter. Anyway. So yeah, just keep doing this. We probably should get rid of the whole frame took. It's really hard to see when we get an update. Next time I see one, I'm going to pause it. There we go. Okay, Control Tab out. Control C. Please stop. Okay. Control C didn't work, but that's fine. I'm pretty sure I stopped it in time. So I'll save that. And sure enough, here's our training data here. So we actually have some stuff in there and stuff. So anyway, what I suggest you do is do this till you have, ideally 100,000. I mean, actually, ideally 1 million. But probably about 100,000 frames, because the other thing that we're going to be talking about in the next tutorial is balancing this data, because it's going to be mostly go straight. And if we send that through a neural network, the neural network's going to really quickly find out, go straight, except in all these outlier circumstances, and it's going to fit to that. It's going to overfit to that. And then when you go to actually use it, your neural network's going to be like, always straight. That's what it's going to do to you. So we have to balance the data. So anyways, that's what we're going to be doing in the next tutorial. If you're having any problems or whatever up to this point, we'll also try in the next tutorial to look at this data just to show you that, yes, this data is working. Here it is. It's beautiful. But yeah, questions, comments, concerns, issues, whatever, feel free to leave them below. Otherwise, I will see you in the next tutorial.